factor the greatest common factor. 36x cubed minus 120x squared plus 108x. 36x cubed, 4 times 9 times x cubed. 8 times 3 times 5, so 12 times 10, x times x. And 4 times 27 times x. This 2, that 3, and this x are common. Greatest common factor, 12x. Now, if we factor out the greatest common factor, we can go further and we can rewrite this trinomial as a product. 12 times x times all of this. All of 3x squared minus 10x plus 9 is a factor. Distribute, see if you get the original trinomial back. 12 times 3 is 36 x times x squared x cubed minus 12 times 10 times x times xx squared. 9 times 12 is 108 times x. Example 4. Factor x minus 7 times 5x plus 3 minus, so this is a difference, x minus 7 times x plus 9. It says factor, not just factor out the greatest common factor. We will say later factor completely. Okay? You write the x minus 7 in the same column, or you could probably see that this is a common factor, so you factor it out. After you factor it out, it's no longer here, it's no longer here. What are you left with? 5x plus 3 minus the quantity x plus 9. 5x minus 3 minus the quantity x plus 9. And this can be rewritten as minus x minus 9. Combine like terms, you get 4x, you get 3 minus 9, or negative 6. You have transformed this difference into a product. Factor x minus 7 times factor 4x minus 6. And at this point, you could even factor out a 2. I am surprised that you can factor out a 2, but I guess you didn't see that originally. So I'm not really finished. This should be 2 times x minus 7 times 2x minus 3. The next example, you're given 4 terms. Greatest common factor 2, no 2, p, no p, x, no x. Greatest common factor is 1. Okay? No factor appears in all 4 terms. So if we have 4 terms, one usual method that may or may not work in these cookbook problems is to pair up the first 2 terms, the first last terms, or the first and the third, and then the second and the fourth. And then factor from each pair. Okay. Suppose we want to factor 40px minus 10p squared minus 30p plus 60x. We can factor out a 2, no 3, a 4, no 4. So we have factored out a 2, we can factor out a 5, a 5, a 5, 5. We can factor out a 10, 10. 10 is the greatest common factor as far as the numbers are concerned. P, no P, X, no X. So P and X are not common, they don't appear everywhere. 10 is the greatest common factor. And we are left with 4 terms. From the first 2, now it's 10 times, don't forget about your 10. I use brackets here because I have parentheses inside. From the first 2, 2 is not common, p times p, p is common. You're left with 2x, you're left with minus 1p. Now, factor out either a minus 3p or a 3 or a plus 3. Make it a minus 3, a 3 here, a 3 here, no x here, no p here. A minus 3 in order to get positive p, minus 2x. Or if you had factored out a plus 3, you would get 2x minus p. Factor out plus 3. because then you are going to get, you make one change here, you make another change here. Remember, I never subtract, I add opposites. So I want to make this opposite because these two factors are supposed to be the same so that you can yank them out. Greatest common factor. So the 10 is copied, the 2x minus p is common. You are left with just a p, you are left with just a 3, so p plus 3. So this is your complete factorization. Instead of pairing 2px and p squared, 2px and p squared, could you have paired 2px and 6x? So 2px and 6x, or 6x squared. Okay, 2px and why do I say 6x squared? What I intended to do is, instead of pairing the first two, could you have paired the first and the third? So I think I should have said, could you have paired 2px and 3p? Well, that's what I'm doing right here. I got 2px minus p squared minus 3p plus 6x. So from these two I can factor out 2x, this one and that one. And I'm left with p plus 3, and then the two middle terms, p squared minus 3p. p plus 3 is common, which I yank out. I am left with 2x minus p, 2x minus p. Is that the same result we had previously? Well, you go and check. It should be.